Hello and welcome to this short video summary of the BA Digital Design and Engineering course. My name is Dr. Alejandro Vélez Reyes. I am a lecturer in digital design and fabrication in the School of Art, Design and Architecture at the University of Plymouth, and I am the course leader for the BA Digital Design and Engineering and the Masters in Integrated Design Innovation courses, which at postgraduate level looks into also the use of digital design technologies in the context of engineering and technology practices. My own background is in architecture. I have been researching material systems and ways of making supported by digital design and engineering technologies, including robotics and 3D printing. And that has covered a range of different areas, such as built environment research, product design and fine arts, as well as other speculative pieces on interior design, digital visualization, and 3D modeling associated to additive manufacturing. In terms of the rationale for this course, this is a course that actually emerges as a response to industrial sectors in need for creative thinkers and creative makers, and the use and the benefits of design methods such as prototyping across a range of engineering industrial sectors such as the automotive sector or the manufacturing sector. Right? This is an emerging area in the UK economy, and there is data supporting the claim that companies that make use of a blend of skills and expertise, including both creative and technical and scientific skills, perform better, everything else being equal, perform better than companies that make use of only creative or only scientific and technical skills. That is not only an industrial question, but there is also a segment of applicants, students in schools across the UK, which actually prefer a variety of A-level choices, not just in the arts and not just in the STEM fields such as science and technology, engineering and mathematics, but that actually choose a mix of those subjects. And there are interests, and there is evidence that demonstrates the interest on subjects and on combinations of subjects that links the arts and design disciplines with some STEM disciplines as well. This is data you can see from Scotland, published in 2014, and you can see that 1 for every 4 students for choosing 4 subjects, and almost 1 for every 3 students choosing 5 subjects make an actually multidisciplinary, if you wish, choice of A-levels. And this is what this course aims to provide, right, as a curriculum. It provides a platform to help you deliver projects by looking into the intersections between creative thinking and digital technologies, right? That can take the form of wearable projects and the use of data in the context of product design, for example, the project you can see on the screen now, or projects that look into technologies such as, in this case, computing and robotics, looking into applicabilities and intersections with robotic art and human-robot collaboration in the context of illustration, right? All these projects involve an element of creative thinking or creative practice, as well as some digital technologies, technical and scientific concepts that underpin this project delivery. In that sense, throughout this course, you can build a skill base, right, that can help you engage with a range of sectors that includes robotics or creative uses of data in the context of, for example, industrial design or manufacturing, particularly in the digital fabrication space. But as a result of that, we are quite discipline agnostic, right? We're quite multidisciplinary in the way we deal with those challenges, and therefore we expect you to not just engage with existing sectors, but actually look into new materials, new modes of sustainable production, or new ways to engage with grand challenges or global challenges. And as a result of that, open and explore the potential for new markets and new business models in the design and engineering space. This course was approved by a cross-disciplinary team of experts, both academic and from industry, including colleagues from the Manufacturing Technology Centre, as well as Autodesk, which is the main software provider in the UK for areas such as built environment, as well as a very important participant in the market of software for other cognate fields such as entertainment and media and product design. And basically what the curriculum does is to provide the tools, the methods, and the processes for you to learn how to move from this initial hunch or idea all the way to a solution to an industrial challenge, right? Is to explore design, right, as a vehicle to help you deliver proof of concept, prototype projects and ideas, and then develop pilot programs and look into minimum viable products for your projects. That is actually a quite established methodology in industry, and every time you develop a technology or an application of a technology to solve a problem, you typically would follow this process. This is called the TRL scale. That stands for Technology Readiness Levels. And this scale helps you move on from that early stages of ideation and research all the way to prototyping and then to further stages of innovation delivery. Now, of course, we wouldn't expect you, right, in the context of this course, to actually deliver something to market. But actually, as you will see a bit later, we do have modules on business and entrepreneurship that will help you look into that space and anticipate what are the new markets and business models that you could explore as a result of your work. Now, this is not a scale we came up with. This is not this is an established methodology of innovation and project delivery, utilizing the UK funding agencies as well as investment and business support frameworks, including the UK Research Councils or Innovate UK, as well as the Technology Strategy Board and some other investment opportunities that look into later stages, let's say, of that innovation delivery process. So in our course, we actually provide design tools and methods and creative thinking frameworks to help you outline how to deal with industrial challenges. What are the issues that we want to solve? What are the materials or processes of technologies that can help you? And that starts from really early stages, conceptualizing, abstracting, discussing ideas in the context of brainstorming sessions, early prototyping, proof of concept stages, all the way up to more elaborate, sophisticated, more finished prototypes of services, products, and experiences. This is, for example, the project of an MA Smart Urban Future students that has developed a framework to allow little communities to engage with energy trading and sustainable energy storage through the use of voice and chatbots, and therefore enable much more sustainable and user-friendly ways to engage with issues around energy. The main space where we deliver our projects is called the Design Lab. This is not just a design studio in the sense that, well, it is a physical place where you will deliver your project. However, it's not only the space where you would design as a sole, an individual thinker. We call it the Design Lab because it's also the space where you would prototype and test ideas with your peers, with industry partners, with associate lecturers and tutors from our program, and is very much industry-driven, collaborative, and an open space for you to share and discuss your ideas with different people, different users, and different students. Right? This Design Lab methodology as a mode of delivery is already implemented in our postgraduate courses on design innovation and in smart urban futures. In order to provide this sense of industry association, right? How do we work with technologies in order to deal with industrial challenges? We have a series of guest lecturers that throughout the year will go to the course and talk to you about how they have set up successful business models or successful projects by creatively using different technologies, including immersion, data, Internet of Things, voice and audio technologies, artificial intelligence, and so on. These are just some of the speakers that have visited our range of postgraduate programs last year, and they cover a range of different areas, and they're very successful in their own fields because they have creatively dealt with different technologies in their own sectors. That includes artificial intelligence, immersive audio experiences, or the Internet of Things. How will your student experience be? So basically every semester is highly driven by your project. So every semester has a design brief that you will address and you will tackle, right, with different tools and the support of our technical and academic staff. And you will submit a project, a body of work, your design lab submission, and a technical report which summarizes all the technological or scientific, right, or computing data aspects, right, of your work. And usually this body of work, right, this project-based experience is additionally supported by one extra module that covers different things and evolves as the program moves on. So in the first year, for example, you have an introductory module that sets the tone for the program and introduces you to some tools and methods. And then that module evolves into design thinking, critical making skills and knowledge around the theory of design and design engineering. And then it moves on to a supporting module on business skills and entrepreneurship in your last year of studies. So in year one, we build the foundation, right? We build the foundation for the program and we deliver the knowledge and skills necessary to competently deliver a project in our design lab environment by addressing the groundwork of different skill sets that you will use throughout the course. And that covers things like 3D modeling, digital fabrication, 3D printing, how do we engage with new materials, and there is a lot of tests and experimentation, right, for you to build an initial toolkit, right, an initial toolkit of skills for you to competently operate in the course, right, that can cover briefs in either the built environment or other industrial challenges, which we will set up for you in the context of our design lab. Once this foundation is set up, in year two, you will be expected to address a further degree of specialization, a further degree of experimentation and digital skills in the context of design and engineering tools and methods. And that can include, for example, engagement with our immersive media laboratory or engagement with advanced methods of using data to design. For example, the table that you can see on screen is a table which has been completely designed by a computer. So what the designer has done was to look into specific constraints and materials and performance requirements, and then the end design result is completely generated as a result of a series of algorithms and computing tools that have estimated that this is the optimal solution for that design problem. In a way, this table is not actually designed by a designer. And these are the type of tools in terms of level of complexity that you will be expected to engage with in year two. In year three, there is an optional placement year, or you can move on directly to the last year of the course. If you go on placement, we will monitor that placement in order to make sure that you learn what is expected from you to learn during that year out in industry. And the aim of that year is, of course, to expose you, right, to different practices and contexts for digital industrialization technologies. And that includes different areas and is very flexible because, as you have seen so far, we are quite discipline agnostic and we are keen to engage with multidisciplinary frameworks of professional practice and multidisciplinary businesses. So your year out in placement could be in the creative sector, it could be in the space of product design or industrial design, or it could be also in engineering sectors, which could benefit, right, from creative ways of thinking, for example, the automotive sector or the manufacturing sector. In the last year of studies, you will be expected to engage more meaningfully with specific areas of design and engineering practice, particularly because you have a supporting module on business and entrepreneurship skills, but also you will have to develop your dissertation. So an element of research will appear at this point. So you will be expected to engage with a bit more depth and a bit more analytically with more sophisticated contemporary methods and context of design and engineering practice. And that can include areas such as robotics or sensing and responsive environments, for example. Or you might want to look outside of the discipline, looking into the application of digital technologies in areas such as dentistry, for example, 3D printing of dental models, or prototyping of medical devices, or prosthetics, or the use of 3D printing for automotive design or built environment applications, and so on. Basically, after the course finishes, you can also engage in this further kind of area of work by joining one of our master's program on either design innovation or smart urban futures, where we work with a series of industry partners, and we actually offer a series of studentships and work with industry throughout these courses, and those projects cover a series of advanced technologies, including audio technology and machine learning, additive manufacturing, robotics, virtual reality and immersive media, etc. So in order to help you deliver these projects, in order to help you get on with your tasks of prototyping, making and testing things, our university has quite recently delivered 2 new labs, a new digital fabrication and immersive media lab. The digital fabrication laboratory includes a quite unique suite of tools to the southwest. Some actually machines and pieces of equipment there are unique to the southwest, but also is the combination of all these tools, and that includes standard FDM 3D printers, 3D scanners and laser cutters, but also includes very specialist equipment such as resin 3D printing for medical applications or dental applications, long-range 3D scanning, or large format CNC milling up to 4x8 foot surface area. Also, we have on campus a facility called the Make Lab, where you can engage with electronics and sensing devices and the design of your own bespoke sensing tools. And they also have a small fleet of 3D printers. And lastly, we also have a new immersive media laboratory, which is being finished at the moment of this presentation, and basically includes all the equipment for immersive media and visualization for our school, and that includes virtual reality and augmented reality, motion tracking, motion capture, a full dome visualization screen, a green screen from filmmaking, and a series of other immersive kind of visualization tools for you to engage with. Lastly, in terms of knowledge exchange, our program, of course, is very much industry facing. We engage with industry partners, as you have seen, but also our university engages more broadly with very ambitious, large-scale frameworks of business support and the use of digital tools in the local industry. One of them is the I Mayflower project, which is a cultural development fund developed by our knowledge exchange team at the Bridge, and we work really, really closely with them, particularly looking into how digital technologies can help drive growth in the local creative economy. And that scheme has funded some studentships for our master's students to join industry partners on the development of some joint projects, such as Tates and Ives, for example. And also, we are part of the Southwest Creative Technology Network and the network of fellowships on immersion, automation and data, and this includes fellowships for academics, for new kind of young talented people, and also for industrial fellows across these areas, across the Southwest. Here you can see the cohort of automation fellows, which includes myself, I have to say, but also a wonderful group of people working in areas such as built environment, data, unconventional computing, arts and crafts, design for health, and the ethics of artificial intelligence. So it's a wonderful group with a range of skills and knowledge in the automation sector. And these are the networks we are part of, or our funding agencies. These are the institutions we are somehow related to in the context of our own research. we are receiving funding from Research England or EPSRC, but also we engage with industry partners like Epson or networks of industry partners through projects like EPIC, which is an e-health productivity project, and we are supporting that project from our digital and design skills. Said that, in terms of the application process, probably what must be mentioned for clarity is that this course also aims at engaging with potential applicants that maybe are a bit more technically minded or might want to engage with the course from a more, let's call it, engineering technical perspective, and therefore we don't ask for a portfolio. And here you can see all the UCAS and A levels information for your application. But if you have any other question, please do not hesitate to either look at the course website for more details or just send me an email directly. That will be all for this presentation, and thank you very much for listening.